Well, we have the question here, question 3. The question says, in the diagram below, not drawn to scale, A, B, C, and D are the vertices of a trapezium having BC parallel to AD. T is the midpoint DB from B, the straight line drawn parallel to the y-axis. The y-axis cuts DC in F and the x-axis in M. Well, now the first question. The first question here, question 3.1. The question says, calculate the gradients of AD. Well, okay, I'm gonna write the question over here. So we have like the question 3.1. 3.1, we want the gradients of AD. So the gradient is given by M. Just to say AD, I'm going to say gradient of AD like this. This is what we're looking for. And we do know that the gradient is given by the change of Y over the change of X. So Y2 minus Y1 over X2 minus X1. Okay, that's my tablet. X2 minus X1. Now, I want to look at my graph, the diagram here. A is the point -8, 6, and then D is the point -2, 0. Now, I can call this X1, okay? The X coordinates is -8 and the Y coordinates Y1, and then this must be X2 and then Y2. So note that what I cannot do is to call this X2 and then that one X1. It cannot work like that. So if this is X2, that must be Y2. This is X1, that must be Y1. Now I'm just going to substitute these values into the gradient formula to find the gradients AD. The gradient of the line AD will be then M AD will be, I'm going to say 0 minus 6, okay, all over 2, -2 minus 8. That's important. Minus 8. Okay. Now that will be -6 over -2 plus 8. Then we have like the gradients. The gradients AD be equal to -6 over 6, which is equal to -1. That's the gradients. Okay, and then the following question is question 3.2. The question says, determine the equation of BC in the form y equal to mx plus c. All right. So I'm gonna write the question here, question 3.2 over here, 3.2. So we're looking for the line, okay, BC, BC in the form y equal to mx plus c. Well, when we look at this diagram here, it is a parallelogram. Okay, we can see that the symbol, the arrow symbol that we see over here and there, indicate that the two lines are parallel. Okay, it is also said in the question here, BC is parallel to AD. Okay, why am I saying that? Because if you have parallel lines, the conditions for parallel lines is that they have same gradients. So meaning the line here, BC, has the same gradients as the line AD. Okay, I'm saying that because the coordinate of C are not given, they're unknowns, so they're just X and Y. X and Y. So we know with 2 points we can make a line, and then we don't know these coordinates. We cannot find the gradients of this line, but we can just say the gradients are common because the two lines are parallel. Okay, I'm gonna say here. See, the gradients of the line BC is the same as the gradients of the line AD, okay, because they're all equal to -1, just because BC is parallel to AD. Okay, so that is given. Now, meaning the line BC will be expressed by the form -1 x plus c. okay, because the gradient must be -1. Now we can substitute a point, the point on the line BC, okay? The only given point in the line is the point B, 8, 10. So we can substitute the value, okay, the coordinate of this point in this equation. I sub 10 for y, and then x is 8. So this will become 10 will be equal to -1 times 8 plus c. Then this will make excuse me, that will be 10 will be equal to -8 plus c. So we can find, if I move the -8 over, that will make 10 plus 8 equal to c, and then that makes c equal to 18. Therefore, we can say the straight line is y equal to -x plus 18. That's the equation of the line BC. Right. The next question says, question 3, excuse me. Question 3.3 says, prove that BD is parallel to AD. Okay. I think I'm gonna move my board a little bit over here. Question 3.3. So the question says that prove that BD is perpendicular, excuse me, perpendicular to AD. We need to prove that. All right, I think I am going to post the same diagram here. Okay, okay, here is the diagram. Now we're going to prove that the line BD, which is this one, okay, is perpendicular to the line AD. AD is this one, so meaning they make an angle of 90 degrees over here, 90 degrees angle there. Well, we do know that two lines are perpendicular if they form, of course, a 90-degree angle, and if the gradients, the product of the gradients is equal to -1. Okay, so in other words, simply means that the gradients of the line BD times by the gradient of the line AD, okay, equal to -1. Now let's prove it. In other words, we are asked to prove this. Now we already know in the previous question that the gradients of AD was equal to -1. Okay, from question 3.1. Now let's find the gradient of the angle BD. Now the gradient of BD, I can do it somewhere here. The gradient also is given by, also we know that the gradient is given by the change of y, okay, over the change of x. Now I want to work out the gradient of BD. This will be equal to what? Change of y's. So 10, I'll say 0 minus 10, 0 minus 10, all over -2 minus 8, -2 minus 8. So the gradient of BD equal to, that makes -10 over -10. So the gradient of BD is just equal to 1. And then we can see this through that gradients of BD times gradients of AD equal to -1, because 1 times -1 equal to -1. That's true. Proven. See, proven. We can also find the length. Okay, another way to calculate this is like, if you find this length, because if it forms if it forms 90 degrees angle, this means that the hypotenuse here is equal to the sum of the square of the other two sides. Okay, so that's another way to solve the problem. Then let's see question 3. The next question is question 3.4. Question 3.4 here. The question says, calculate the size of the angle BDM. Okay, I am going to move my board over here. Okay, question 3.4. We're looking for the size of the angle BDM. Okay, now let's first draw the same diagram over here. Now put the diagram over here. Okay, actually the diagram is there. I don't like this. Sounds does look so nice. Okay. All right, so we have like the diagram there. Right. To find this angle, we know it's the angle BDM is the angle formed from the horizontal line, the x-axis, to the line BD, this angle. Now, I think the shortest way to calculate this is to find that the gradient BD, okay, because we know that the gradient is equal to, or maybe the tangent of the angle, tan of the angle, okay, is equal to the gradient. So if I find the gradient BD was calculated in the previous question, we did find that M BD was equal to 1, okay, in question 3.4. You can check it over here. The coordinate of BD was equal to 1. Now, if we do, so we can do tan of the angle, tan of BD, in other words, which is theta, will be equal to 1. And then we can use a calculator, but I know here tan of theta equal to 1 implies that theta equal to 45 degrees, okay? If we're sure, you can use a calculator. In the calculator, for instance, I'm gonna say, you can just check, you press shift, okay? 10, 45. Excuse me, I meant shift 10, 1. Okay, this is the inverse. This will tell us the angle. The angle is equal to 45 degrees. So I think this is the short way of solving this problem. Or otherwise, we can also check. We can also find the angle by, you can see we have like a triangle over here. Let me draw a triangle. We have like another triangle over here formed by BDM. Okay, and then it is a right angle triangle. That's 90 degrees. Now, we have the angle theta here. We can also say that the length BM, okay, over, we can say 10 of the angle. We know that 10 of the angle theta is equal to the opposite side, opposite over adjacent, to the y over x, opposite over adjacent, that opposite the angle, and then that adjacent the angle. So in the vertical here, opposite the angle, because it's a vertical line, we can see that that is equal to 10 units. Okay, so that's 10 units because the y value is 10. And then in the horizontal here, this is how many units? Because from over here we have like 8 units. The x value, because the x value is 8. You can also see the 8 over here, 8 units over here. Now, from -2 to 8 is also 10 units total. So we have another 10 units there. So we can say 10 of theta will be equal to 1 over 1. And then, which means 10 theta is just equal to 1. And then if we work out theta, it's going to be 45 degrees as we calculated earlier. Okay. Okay. So let's see. The next question is question 3.5. Question 3.5 says, if it is given that TC is parallel to DM and points T and C are symmetrical about line BM, calculate the coordinates of C. All right. I'm gonna move my board over here. Okay, let's just draw a line. Uh, 3.5. I think I'm gonna draw the same diagram here so we can yeah, excuse me. I'm going to post a diagram here, and then question 3.5. So when they say that TC is symmetrical to BM, so it means that they're also equidistant. Okay, let's first go back and read the question over again. I think we need to read the question again. So it is said that if it is given that TC is parallel to DM and points T and C are symmetrical about BM. Okay, symmetrical means that equidistant. Okay, the line BM passes through the midpoints of the midpoint of the line TC. Okay, you can split TC halfway. Okay, and then calculate the coordinate of C. All right, let's move over here. I think I can just post some the question also over here. Let's just do it. Here it is. So it is said that if it is given that TC, okay, is parallel to DM, so meaning I can just draw the line here. You see, I'll draw a dashed line so we can see it well. So TC parallel to DM. Okay. This line here, this is the line DM, and then parallel to TC. Then now let's say also this also say that end points T and C are symmetrical about the line BM. Okay, symmetrical, as I say, BM is this line, meaning this point is the midpoint of at this point here. It's the midpoint of TC, the midpoint TC. Okay, calculate the value or calculate the coordinate of C. Now, I think, okay, see here, the coordinate of C are unknown, x, y. Okay, we can find the coordinate of C by using the midpoint formula here. No, we can first find T first, because T is also unknown. T is also unknown. Also the points xt are going like that, and then yt. But it is clear that T is the midpoint of DC. Okay. The symbol that we see over here, this one and that one, indicate that they are midpoints. So I'm saying this symbol, wait, this symbol and that symbol indicate that TC is the midpoint. So we can find T, excuse me, indicate that the point C is the midpoint, okay? The midpoint of BD. So T is the midpoint of BD. We can find it. The midpoint is given by, I'm gonna write it over here. The midpoint is given by XM will be equal to, a little bit down, and then this a little bit up. Okay, XM will be equal to X1 plus X2 all over 2, and then YM will be the points Y1 plus Y2 over 2. That's the midpoint. Now T, then the coordinate of T will be the X coordinate of T will be -2, okay, plus 8 divided by 2. So this will be xt will be -2 plus 8 over 2, and then yt will be equal to 0 plus 10 over 2. So t will be -2 plus 8 over -2 plus 8 is 6. 6 divided by 2 is 3. And then 0 plus 10 is 10 over 2 is 5. So t is the 0.35. Now we find the value of the coordinate of t. Then we can find c. But before we do that, let's first find the midpoint TC. Okay, the midpoint TC, we already know that the x value is 8. Then, meaning from t, from 3 to 8 is 5 units. Okay, because it's the midpoint, meaning that also we're going to add another 5 units from m to from MTC, the midpoint, to the coordinate of c, the x coordinate of c, which is so 8 plus 5 is going to be 13. We can still calculate that using the midpoint. So we can find MTC. MTC would be XC. The x coordinate of c will be 3. Okay, this 3 for t. This one plus okay, voila. Because this is an horizontal line, okay, we don't really need to work out the y value. Okay, we know the y value will be still 5 here. Exactly 5, the same 5 as 5, the y value of the point t. Okay, because the line is horizontal, parallel to the x-axis, so it has the same y coordinates. So the y coordinate here is still 5. Now, I was saying from 3 to 8, the x coordinates of TC, of the midpoint TC, is 5 units. And then because it's symmetrical, meaning it has the same unit. Okay, if 5 units from T to MTC, it's also 5 units from MTC to C. Okay, so we plus 5 to 8 to get 13. Or you can also check it up by using this formula. As I said, the midpoint, we can say, okay, the midpoint TC, XM here will be equal to XM is already given, it's 8. So XM is 8 already, okay, which will be so over here C is 3, okay, plus X there over 2, XC over 2. That's the X coordinate. The y coordinate is already defined because the horizontal line is 5. It has the same y coordinate as this. Now we can just work out this 8 equal to 3 plus xc all over 2. If we cross multiply, because over here it's like over 1. If we cross multiply, you get 16 equal to 3 plus xc. And if we move the 3 over, that makes xc equal to 13. This is the same 13 I said we got here for C. So C, the point C is 13, 5. So those are the coordinates of the point C. Next question, question 3.6. Question 3.6. The question says, calculate the area of the triangle BDF. Okay, I think I'm going to move my board again this way. Question 3.6. What they say, we want the area of the triangle BDF. All right, let's first redraw the diagram over here. Okay, here's the diagram. So the triangle BDF is basically the triangle that we see. Okay, I'm gonna show it here. It's this triangle. This one. Okay, we're looking for this triangle. Basically, this one. approximately, okay, approximately this triangle we're looking for. Now, how can we solve this one? Okay, I can see many different ways of solving the same triangle, but I prefer to go through what I think is the easier way of calculating the triangle, because I can see there's another triangle. Okay, let's first remove this. I'm gonna get back to it later. Let's take it off. We can notice that we have another triangle over here. The triangle BDM, okay? And then in the triangle BDM, we have like two triangles. We have the triangle this one, okay, which I'm struggling to draw to really show over here. Okay, yeah, I got it. And then we have like two triangles. I call it like triangle 1 and triangle 2. Triangle 1, area 1 and area 2. The 2 forms the area of the triangle BDM. Okay, so if you work out, I prefer to work out the triangle BDM, okay, everything, because it's easier to calculate, and then subtract like the area of this triangle, and then we work out. So it's gonna be like, I wanna say the triangle BDF, okay, will be equal to the whole triangle BDM, okay, minus the area of the triangle FDM, something like that. Okay, okay, I guess you get it, because BDM is the whole thing. Okay, if I take out FDM, area 2, the second area, FDM, then I got BDM, only this part. So remember what we learned in previous grades, what we call composite shapes. So let me just label them like as I did there. Say here is a triangle BDF, and here is a triangle FDM, and the whole thing here, this is the triangle, this one is the triangle BDM. Now let's do BDM equal to what? The area of the triangle first is given by a half times base times height. Okay, so therefore BDM will be, the base of BDM is 10 units, because over here it's -2, there it's -2, and then that's 8. From -2 to 8, it's 10 units, okay? Because you can count with me, -1, and then 0, 2 units here, and then from 0 to 8 units. So 2 plus 8 makes 10 units. And then on the vertical also, it's 10 units, because you can just look at the Y value there, it's 10 units. So we have like a half times 10 times 10, and BDM will be equal to, that makes 50 square units, okay, or units squared. Now, I can also use the same formula to find the area of the triangle. I call it FDM, but I prefer to say it doesn't really matter, okay? Yeah, FDM. FDM will be then a half times, the base is still 10 units, because in this triangle over here, the base is still 10 units. We are here. Okay, if I can do this, you can see it clearly, maybe. Not that one, but okay, I guess you see the formula, the triangle I'm talking about. The height then would be 3 and a third. So times 3 and a third. Okay. Times 3 and a third. Okay, 3 and a third. I prefer to write it. 3 and a third is equivalent to 10 over 3. Okay, I prefer to write 10 over 3. So if we work this out, this is going to be, we can calculate it, 3.5 times 10 times 10 over 3. This is equal to 50 over 3, okay, which is 16.6666. Okay, let's just keep 10 over 3. What am I saying? 50 over 3. Okay. Therefore, the area then, okay, of the triangle BDM will be equal to 50 minus 50 over 3. Okay, so to work this out, we can just, because 50 here has a denominator of 1, so we can make it we can make it the denominator of 3. So if we times by 3, we times also by 3 there, and then this will be 150 over 3 minus 50 over 3, and this is 100 over 3. Okay, and then we can find the area. Therefore, the area of the triangle BDM will be equal to 100 over 3 is like 33.333333. So this will be like 100 divided by 3 is 33.33 square units or units squared. So that's the area of the triangle BDM. I think this is the shortest way to calculate this area. Thank you.